Hey team, unfortunately one of my videos didn't record. I'm going to do this again, but this is a huge one. So example 23, I'm going to do question C. I've got the working solutions in, as you can see there, but this is, I'm going to do it from scratch again. So here we go. We've got y is equal to, so this is part C, y is equal to 2 times sine of 2 times x minus pi on 3 minus root 3. And the domain is between 0 to 2 pi. Okay, let's start off by sketching what the graph could look like. Okay, so we start off by identifying we've got amplitude 2, period is, that's a dilation of factor half, so remember the reciprocal of 2. So normally it's 2 pi, but you are compressing it by a factor of half. That's why it ends up being pi as your period. This tells me that it moves to the right by pi on 3. This tells me down root 3. Okay, so when I sketch this as a general idea, okay, you always do a general idea. You don't go full blown. Okay, so just do a general idea of what it could look like. What you have to understand is it used to be, so maximum, the amplitude usually should be a 2 and then minus 2, right? What they've done here is you've got down by root 3. So that means you're going to go down by root 3, and it is your job to understand root 3 is less than 2. It's about 1.5 or 4 or something like that. So when you go down by root 3, you can expect it to still be somewhere, I don't know, let's say there. So it's 2 minus root 3, whilst this one drops down. So it goes from down to now negative 2 minus root 3. Okay? And the reason why I emphasize this is because sometimes if it's not root 3, you have to know that, say this was 1, we know that 1 minus root 3 will bring you into the negative region. So it does matter with some logic here, okay? So what I'm trying to say here on a visual aspect, this is your new maximum value. That's your top value, not 2 and negative 2 anymore. It is 2 minus root 3, and the other one is now at negative 2 minus root 3. All right, where's the center? Well, remember, you normally start for a sine graph. Sine graph normally starts off 0, and then, so normally it's 0, but since it's going down by root 3, my now new center is now gone down by root 3. So let's just say here, that's negative root 3 there. So this is my new center. Okay, so if you can visualize that. From here, remember the starting point usually is at 0. But because they've moved to the right by pi on 3, remember, moves to the right by pi on 3, well then, that means instead of it being at the center, it's now moved to the right by pi on 3, and it's gone down by root 3. So the center now is right here. Okay, so it's moved to the right by pi on 3, and it's gone down by root 3. This is important to know because this now starts off a picture for you. You now know this is your starting point, pi on 3. So I'm going to write here starting point as pi on 3. Period, we knew was pi, right? But remember, your job is to find the next quarter cycle because quarter cycles allows you to find, so every quarter cycle you get from center to maximum to center to minimum to center to maximum to center to minimum to center, and it follows that pattern. So if you know how long it takes to get to the maximum or each quarter cycle, you can predict what the graph looks like. So from here, quarter cycle, we know that QC, I'm going to call it as quarter cycle, is pi, divide that by 4, because we're finding quarters, which is pi on 4. So that means you're starting off at pi on 3, this is the spot you're starting. To get to the next quarter cycle, you need to add on an extra pi on 4. So let's work this out. Let's work out our pattern here. We need to get to the next quarter cycle, we need to add another pi on 4 to the starting point. But when you add it, notice that the denominators need to be the same. So I'm just going to highlight this, 3 and 4. So I'm going to change this now. So times this by, oops, I'm going to do another color. Times this by 4, times this by 4, times this by 3, times this by 3. So you get 4 pi on 12, which is the new starting point. So I'm going to change this now. Instead of pi on 3, it is now 4 pi on 12. All right? And I'm adding an extra, the quarter cycle, which is pi on 4, is the same thing as 3 pi on 12. So that means I'm adding on an extra 3 pi on 12 every time. So now I know to get to the next quarter cycle, it has to be an extra 3, which now makes it 7 pi on 12. An extra 3 is now 10 pi on 12. An extra 3 is now 13 pi on 12. And then I can continue on. Right, I'm just going to carry it on. Now, we know that the domain, remember what was the domain? It was from 0 to 2 pi. So 0 to 2 pi means that I would have to go from 0 to 2 pi. That would be 0 all the way up to 24 pi on 12. True? If I'm working in fractions of 12ths, right? So that means I can follow on the pattern 10 over 12, 13 over 12, 16 pi over 12, to another 19 pi over 12, to say 21 pi over 12, and then how beautiful is that? We finish off at 24 pi on 12. So this tells me if I follow the quarter cycle pattern, starts on center, remember sine graphs go up and down, right? So that means from center it goes up to the maximum at 7 pi and 12, goes down to the minimum, the center at 10 pi and 12, to 13 pi and 12 it gets to the minimum, back to the center, back to the maximum, back to the center, back to the minimum. True? And now you also have to work backwards as well. So 4 pi and 12 minus 3 now. So I was adding 3 before. Now I'm going to minus 3. So that brings me to pi on 12. Okay, so pi on 12 will bring me to the minimum. And then obviously there's a y-intercept somewhere that I need to figure out. I'm just going to rub this one out to not confuse you. So we know that if we go another quarter cycle, it would bring me to negative 2 pi on 12 because I'm minusing 3. And that would bring me to the center. So this is what it should look like that. But remember, the domain is only from 0, so I have to cut it off and only draw it from here onwards. Actually, I should do it in black so it's easy. Yeah, I'll do it in black. So here, 0, past there, past there, past there, past there, past there. But we know that it technically would have gone to the center. True? So you don't sketch that dotted line that I just did. This is the shape of my graph. So technically, I'm almost done. I've got some of the endpoints. The things I'm missing now are x-intercepts. I don't know what, I can already see there should be 4 x-intercepts based on what I'm seeing there. And I need to know what the y-intercept is. Okay, so y-intercept, x-intercepts. That's what I need. Okay, so y-intercept, x-intercepts that I've got here, there should be 4 of them. And then endpoint. Okay, but the endpoint happens to be nice. It's exactly at 2 pi. It's at the minimum. So I already know at 2 pi, it should be negative 2 minus root 3. That's my endpoint there. Okay, so I've got my graph there already. The only thing I'm missing is y-intercept and turning point. So x-intercept. Y-intercept and x-intercept. So y-intercept is easier to do, so I'm going to do it here so you can see. To find y-intercept, how do you normally do it again? You let x equal to 0 and you find y, right? So let x equal to 0. So in our equation, what's our equation again? It was y equals to 2 times sine of 2 times x minus pi on 3, all minus root 3. Woo! That's a nasty one. So here we go. We're going to let x equal to 0. So that now changes it to y is equal to 2 times sine of 2 times 0 minus pi on 3. All minus root 3. It looks all scary, but let's simplify it. 2 times sine of, and that essentially becomes negative 2 pi on 3, minus root 3. And now this is where you have to use your exact values and symmetry properties. Work out what sine of negative 2 pi on 3 is. So hopefully you can do it in your head, or if you can't, I'm drawing a unit circle for you. Negative 2 pi on 3 means that you're in quadrant 3. So that's the same thing as finding the negative, because sine is negative in that region. Sine's the y values are negative. So this is the same thing as finding negative sine of pi on 3. So this essentially is 2 times whatever that is, and then minus root 3. And now using your exact values, that is now negative of root 3 on 2 multiplied to 2 minus root 3. And we can see 2 divided by 2 cancels out to be 1. And so you now have negative root 3, take away root 3, gives you a nice negative 2 root 3s. Okay, so you can see why this is tricky for a lot of students, because, surds, fractions, unit circle theory, there's a lot going on there just to find the y-intercept, and that's meant to be the easiest one to do. Okay, so that's to find y-intercept. Now, I still need to find x-intercept. Now, the y-intercept, let's just fill this in. I'm just going to rub this out so it's not too confusing. The y-intercept should be now at, when x is 0, it was negative 2 root 3. Okay, so I've got my y-intercept. I need my x-intercepts now, All right, so x-intercepts, there should be 4 of them, and this is what makes it tricky, but I'm going to show you how I do it. So here we go, x-intercept. How do I find the x-intercept? Let y equal to 0. So here we go, let y equal to 0, and our equation will be 0 is equal to 2 times sine of 2 bracket x minus pi on 3 minus root 3. Okay? And don't forget the domain was 0 to 2 pi. Now I'm going to show you what I do. I'm sure there's a lot of different ways to do this to get the same answer, but I'll show you how I do it. Okay? So I'd say add root 3 on both sides because that's minus. So add root 3 on both sides. Minus root 3 plus root 3 cancels out. You end up with root 3 is equal to 2 times the sine of 2 bracket x minus pi on 3. Most students are afraid of this section here. Okay. This next part's pretty easy. Divide both sides by 2 because that's times 2. And we know that 2 divided by 2 cancels out to be 1. So now you've got something a bit more familiar. Root 3 over 2 is equal to the sine of 2 bracket x minus pi on 3. So this is where it's key. So right here, you're essentially trying to solve for sine of what angle. So this is just an angle. Sine of what angle gives you root 3 on 2. So when you think about the unit circle, all they're trying to say is sine, which is the y values, need to be root 3 on 2. So root 3 on 2, say it's up here because it's positive. Then there's only 2 points in the unit circle that can happen, right? And so your question now is, well, what is the angle? Sine of what will give you root 3 on 2? And hopefully, you know now it's 60 degrees, and that means the distance is pi on 3, and this is pi on 3 in this direction from the x-axis, okay? So that's my picture right now. That's what I'm working out for. What makes this tricky is what the domain is. Now, the domain was from 0 to 2 pi, correct? How I do it from here, so obviously to get rid of the sine, you do sine inverse of both sides. That cancels out sine inverse of the right-hand side. So essentially, you're now writing, I'm just going to flip it around, yeah? So this is 2 times x minus pi on 3 is equal to, what is the sine inverse of root 3 on 2? What I do, okay, this is how I do it. I know that there is a dilation factor of 2, okay? So what that means, sorry, dilation factor of half. But to work in halves is actually really hard. So what we do in one of my previous videos, if we go back to how to solve, I'm just going to go to H. I did a video on how to do example 20 when you have that 2 there, and I show you a technique on what I do there, yeah? So I times I expand it hypothetically. I expand the domain. So because there's a times 2, what I'm going to do here is then 2x will be between 0 and 4 pi. That's what I would do. Okay, so this is how I do it. I expand it. So instead of going from 0 to 2, I'm now doing from 0 to 4. So essentially I'm doing 2 revolutions. Okay, so that means I end up with 4 solutions, because if you do 1 revolution, notice you pass the solutions twice, 1 and 2. And that's why if I do 4 to 4 pi, which is 2 revolutions, I end up with 4 solutions, which makes sense because in the graph it clearly shows I have 4 solutions there. So this is how I would do it. I know I'm going to go around the circle 4 times, but what I like to do, okay, this is how I do it. I just work out the first 2 solutions, and it doesn't matter what the domain is. I literally don't care if it's negative pi to say pi. It doesn't matter. I still work from 0 to 2 pi. Okay, so that's what I do first. I just ignore it. I find the first 2 solutions. Okay, I find the first 2 solutions. So here we go. First 2 solutions, imagine it was 0, starting at 0. I move up. That's pi and 3. So I go 0 plus an extra pi and 3. Then the other one has to be then pi minus pi and 3 to get my second solution. True? So here I would know already that my possible answers is at pi on 3 and pi minus pi on 3, which is, 3 times pi, 2 pi and 3. Cool? So what I do here is that I know I'm going to move all the way to 4 pi. So what I'm going to do is I'm just going to write all the possible solutions if I added on the period. Now the period technically, okay, hopefully I'm not going to confuse you here. See, the period we said was pi, correct? But in this hypothetical world, I'm not going to work with pi because it just makes it too hard. So I already extended the domain. So I'm going to work with a period of 2 pi because the unit circle I'm working with is actually a 2 pi period, not a pi period, right? So I'm going to doing this hypothetically. So what I'm going to do here is I'm going to add 2 pi to both, and I'm also going to subtract 2 pi to both until I pass the domain, minus 2 pi. So until I pass 0 and I pass 4 pi, because I know that's my limit. Okay, so here we go. I'm going to just work it out. I'm going to say, let's add on 2 pi. Now, if you add on 2 pi, let's say I'm just doing on a side, pi on 3 plus 2 pi. In my mind, this is the same thing as saying pi on 3 plus 6 pi on 3. So I'm just adding 6 every time. So here we go. Let's do it. I'm going to write all my possible solutions. Okay, so from here, what I'm going to do is I'm going to add on 6 pi on 3 every time. So that means pi on 3. I'm going to add, so again, this is 2 pi on 3. I'm going to add 2 pi. So when you add 2 pi, it's like adding another 6, right? So that now becomes 7 pi on 3. Then if I do the same thing for this one, so I'm adding 2 pi for that one. If I add 2 pi to this one, then that's like adding another 6. So add another 6 to that is 8 pi on 3. And then you can keep going if you want. You can just keep following that same pattern. Add another 2 pi. And you're going to add another 2 pi. And what you're going to get is you're going to get, what? If you add another 6, which gives you 13 pi for this one. And the other one is 14 pi on 3. But what you should notice already is I've already passed my domain. So my domain was 0 to 4 pi, right? So 4 pi should be 12 pi on 3. That's 4 pi. So that means I should be stopping anywhere between here, right? So these solutions are totally too far now. Then I got to go the other direction. I got to check in the other direction as well. So I'm going to go pi on 3 minus 2 pi because it's going the other revolution. And then same thing with this one. I'm going to go backwards. I'm going to go this way. All right. Actually, maybe I should do it like this. Minus 2 pi, whilst this one is, again, minus 2 pi. So when I go in that direction now, can you see I can get 2 minus 6 gives you minus 4 pi on 3, whilst this one, 1 minus 6 is negative 5 pi on 3. Can you see that? And that's already, you can already see that's passing my domain. The domain was from 0 to 4 pi, yeah? So 4 pi and 0 cuts off here. That's where 0 is. That's my domain. That's my eligible domain. So that means these solutions are out. Negative 5.3, negative 4.3 does not exist. And then also 13 pi and 3 and 14 pi and 3 doesn't exist. But my possible solutions are pi and 3, 2 pi and 3, 7 pi and 3, and 8 pi and 3. And this is where there's a lot of movement because if you have a horizontal translation, sometimes one of these solutions end up falling into it. So you're meant to actually work out another 2, but I already know it's fine. That might confuse you. So just stop here for now. Okay, so what I'm trying to say is that we got up to this step. We did sine inverse of root 3 on 2, and I've got my answer as, so remember, still 2 times x minus pi on 3 is equal to, and you've got 2 solutions here. You got 2 pi on 3, 7 pi on 3, 8 pi on 3. Okay, and then from here, what you can do is now you can try adding on, you can then try